has involved in the integration of multi-modal technology that has been developed during the multiple projects for one of the monitoring system in food case of study. So yeah, I have the table of contents that I will follow throughout the presentation. So first of all, well, I will start with the goal of the monitoring system. So as I said before, IRIS has involved in the integration of food monitoring system. And one of the monitoring stage we have been looking at is the conching process. So the conching process is an important stage of the chocolate manufacturing process. So this process consists in mixing, stirring and agitating the chocolate mixture for a long period of time to improve the taste and the texture in order to produce a more smooth product. So it is known that texture and viscosity are one of the most important key parameters of cocoa products, and especially for chocolate production. So currently, particle size and viscosity are performed with earth-line measurements, which samples are taken manually from the conching machine to be measured close to the process. So these earth-line measurements for the chocolate can be time-consuming since a few samples can only be analyzed, and also someone has to be constantly present to perform the measurement to ensure the end point of the process. So for this reason, the aim of the continuous monitoring system in multiple projects is to improve the quality control by using an online monitoring system to measure the particle size and also the viscosity as a quality control characteristics. So IRIS has involved in the monitoring system for JOTIS case of study in the conching process. So let me introduce you to JOTIS. JOTIS is one of the largest and leading food production in Greece. And the company mainly focus in the production of baby food. But however, nowadays they have brand products of portfolio, such as products like dry mixes, chocolate or syrup. So they also export their products to many European countries and also Asian and United States. So far, two devices have been already integrated for monitoring during the conching process. So the first sensor is the senorics sensor, which was developed by the senorics as part of the multiple projects, and it was integrated by IRIS into the conching process. So the second sensor is the IRIS device, commercial device. So this sensor was used as a benchmark product. So the two devices were in the range of shortwave infrared spectroscopy range. For the case of senorics, the spectral range is from 1,200 nanometers to 1,700 nanometers. And in the case of IRIS device, the spectral range from 900 to 1,700 nanometers. So the two devices differ mainly in the number of bands, while the senorics sensor has a total number of weights of 16 bands. And for the IRIS device, it has a number of wavelengths of 256 bands. So here I have some pictures of the monitoring system or the bypass system that has been performed at JOTIS facility. So as you can see here, we have the conching machine. So the conching machine is already connected into a pipe connection. So, and it's also adapted to the two devices that has been developed well. The senorics devices that have been developed during the multiple projects, and the IRIS device, which was used as benchmark product. So here you can also see the bypass system that have been implemented into the conching machine. So regarding the data flow, first of all, we have, as you can see, first of all, we have the chocolate. So the chocolate passes through the two adapters. So these two adapters were mainly used in order to enable the implementation of the two devices into the bypass system. So once we have the chocolates that passes through the adapter, the sensors give a signal. In this case, we obtain a spectrum for each of the devices. And furthermore, this spectral passes through the software device, the software that has already been implemented into the two devices. So in this software, we have built already two chemometric models for each of the device. These models are for the particle size in order to estimate the particle size, and the other model is in order to quantify the viscosity of each of the samples. So finally, we can predict a new samples through a computer system that allows us to visualize the result of the predicted value. And regarding how do we manage this data, so all this data that are generated are stored into the device data log. So here I have an example of the use interface that we have built with the software, which is already implemented in the two devices. On my left hand, we have the interface where we can visualize the spectra obtained from each of the chocolate signal. And on my right side, we have the interface that allows us to visualize the predicted values, both for the particle size and also for the viscosity. So yeah, I also have a video that we took during the integration of the two devices at Jyoti's facility. So I'm going to play the video to see how the conching process works, and also to visualize how the bypass of the online measurements with the two devices have been implemented. So I'm going to play the video now. So at the beginning here, we have the chocolate inside the conching machine, which is doing the mixing and the agitating. So as you can see here we have the pipe whereby the chocolates come out from the pipe and it goes through the bypass they have built for an online measurement for the two devices. So after the bypass, we have here the two adapters that allows the connection of the two devices. Here we have the multiple project device that have been developed. And here we have the Iris device, which was used as a benchmarking product. So all this, the two devices have been connected into the computer system. It has a software that's already implemented, and that also allows us to visualize the spectra. Here we have the spectra for the benchmarking product. And here we also have the interface that allows us to visualize the results. So on the other hand, we have the senorics sensor as well. So here we can see the spectra that is generated during the measurement. And here we have the results obtained. So, sorry. So yeah, and that's it.